When installing grounding for portable buildings, it's important to address concerns about creating multiple paths to ground. Multiple ground rods can create parallel paths, which can lead to uneven distribution of fault currents and potential ground loops. This can compromise safety and equipment performance. The additional ground rod could interfere with the proper grounding of the service system, as it would create an alternative path for fault currents. According to National Electrical Code Section 685.24, portable buildings must have a grounding wire connecting the ground bus to the frame. NEC Section 250.53 indicates that ground rods are not necessarily required for portable buildings. Consider discussing these concerns with the inspector, explaining the potential issues with creating multiple paths to ground and interfering with the service grounding. As an alternative grounding method, suggest using a single ground rod for the portable building site and bonding all buildings to it. This would provide a single, well-defined ground reference. If necessary, consider consulting with an electrical engineer to provide a design solution that meets code requirements while addressing your concerns. When planning for future expansion of buildings, ensure that the proposed grounding system can accommodate the expansion without creating ground loops or other issues. Soil conditions at the site may also impact the effectiveness of ground rods. Consult with a qualified electrician to determine the appropriate type and number of rods required. Grounding is essential for ensuring the safety of occupants and equipment. Ensure that all grounding connections are properly made and maintained. Consider the overall grounding system design, especially when dealing with multiple structures in a 400 amp service. It is crucial to maintain a low impedance ground path to facilitate the quick operation of overcurrent protection devices in the event of a fault. A ground loop can occur when there are multiple ground paths, creating voltage differences, leading to circulating currents that can cause electromagnetic interference and equipment damage. Ground loops can be avoided by ensuring a single point of ground reference and proper bonding techniques. The grounding electrode system must be installed per NEC 250.50. This generally requires that all grounding electrodes that are present at each building or structure served be bonded together to form the grounding electrode system. This includes items such as metal water pipes, metal building frames, and ground rods. Because ground rods are considered to have limited effectiveness, NEC 250.53 requires that a single ground rod be supplemented by an additional electrode, such as another ground rod, or the metal frame of the building if it meets certain criteria. In many situations, the most effective grounding electrode is the metal water pipe, as described in NEC 250.52 because it typically provides the lowest ground impedance. However, it must be supplemented by another approved electrode. Where metal water pipes are not available, the building steel can serve as an effective grounding electrode. NEC 250.52 ATWA requires that the building steel be connected to the grounding system if it is connected to the earth, is at least 10 feet in length, and is encased in concrete. If neither a metal water pipe nor building steel is available, ground rods or ground rings are permitted by NEC 250.52 5 and 6. If using ground rods, it is important to ensure they are installed at least 8 feet apart. If the resistance to ground of a single ground rod is greater than 25 ohms, it must be supplemented by an additional ground rod. Proper bonding is also crucial for maintaining a safe and effective grounding system. Bonding ensures that all metallic parts are at the same potential, minimizing the risk of electric shock. Main bonding jumpers and equipment bonding jumpers should be sized according to NEC 250.28 and 250.102 respectively. These conductors must be sized appropriately based on the size of the service entrance conductors. The equipment grounding conductors that run with the circuit conductors must be sized according to NEC 250.122 based on the rating of the overcurrent protection device. For example, a 20 amp circuit requires a 12 American wire gauge copper equipment grounding conductor, while a 60 amp circuit requires a 10 American wire gauge copper equipment grounding conductor. When dealing with portable buildings, it is important to consider the flexibility and transportability of the electrical connections. Flexible metal conduit can be used for connections that require movement or vibration, but it must be properly bonded. The bonding requirements for flexible metal conduit are specified in NEC 250.118. For example, if flexible metal conduit is used as the equipment grounding conductor, it cannot exceed 6 feet in length and must be terminated in fittings listed for grounding. Alternatively, a separate equipment grounding conductor can be installed inside the flexible metal conduit. Ground fault circuit interrupters, or GFCIs, provide an additional layer of safety by detecting ground faults and quickly de-energizing the circuit. GFCIs are required in many locations, such as bathrooms, kitchens, and outdoor areas, as specified in NEC 210.8. They are particularly important in portable buildings where the risk of ground faults may be high due to environmental factors and frequent movement. Surge protection is another important consideration, especially for sensitive electronic equipment. Surge protective devices, or SPDs, protect against voltage surges caused by lightning strikes or other electrical disturbances. SPD should be installed at the service entrance and at downstream panels to provide comprehensive surge protection. The selection and installation of SPD must comply with NEC 285. Regular inspections and maintenance are essential for ensuring the continued effectiveness of the grounding system. Check for loose connections, corrosion, and damage to grounding conductors and electrodes. Ground resistance testing should be performed periodically to verify that the grounding system is functioning properly. Soil resistivity can also affect the performance of the grounding system. High soil resistivity can increase the resistance to ground, making it more difficult to dissipate fault currents. Soil resistivity can be improved by using ground-enhancing compounds or by installing additional ground rods. In some cases, a ground grid may be necessary to achieve the required ground resistance. A ground grid consists of a network of interconnected conductors buried in the earth, providing a large surface area for dissipating fault currents. When working with electrical systems, always follow safe work practices and wear appropriate personal protective equipment, or PPE. This includes insulated gloves, safety glasses, and arc-rated clothing. Always de-energize circuits before working on them and verify that they are de-energized using a voltage tester. Lockout and tag-out procedures should be followed to prevent accidental energization of circuits. Understanding the relevant NEC articles is crucial for ensuring compliance and safety. Article 250 covers grounding and bonding requirements, while other articles address specific applications and equipment. Staying up to date with the latest edition of the NEC is essential, as codes and standards are regularly updated to reflect new technologies and best practices. Consulting with qualified electrical professionals is always recommended, especially for complex or critical installations. Electrical engineers and licensed electricians have the knowledge and experience to design and install safe and effective grounding systems. They can also provide valuable insights and recommendations based on their expertise. Proper grounding and bonding are essential for protecting people and equipment from electrical hazards. By following the NEC and implementing best practices, you can ensure a safe and reliable electrical system for your portable buildings. Remember to always prioritize safety and seek professional guidance when needed. The overall goal is to create an electrical system that minimizes the risk of electric shock and provides a safe environment for occupants and equipment. The grounding system plays a critical role in achieving this goal. By understanding the principles of grounding and bonding and following the relevant codes and standards, you can create a safe and reliable electrical system for your portable buildings. Firstly, consider the type of soil. Soil conditions affect the performance of ground rods. Sandy soil is a poor conductor, while clay soil is a better conductor. Secondly, the depth of the ground rod should also be considered. Ground rods should be driven deep enough to reach moist soil, typically at least 8 feet. Thirdly, the spacing of ground rods is important. Ground rods should be spaced at least the length of the rod apart. For example, if you are using 8-foot ground rods, they should be spaced at least 8 feet apart. Fourthly, the size of the grounding conductor should be appropriate for the size of the service. The grounding conductor should be sized according to NEC Table 250.122. Fifthly, the grounding connection should be made properly. Grounding connections should be tight and corrosion resistant. Sixthly, the grounding system should be inspected regularly. Grounding connections should be checked for looseness and corrosion. Seventhly, the grounding system should be tested periodically. Ground resistance testing should be performed to verify that the grounding system is functioning properly. Eighthly, ground fault protection should be provided. Ground fault circuit interrupters, or GFCIs, should be installed in areas where there is a risk of ground faults. Ninthly, surge protection should be provided. Surge protective devices, or SPDs, should be installed to protect against voltage surges. Tenthly, the electrical system should be designed and installed by qualified professionals. Electrical engineers and licensed electricians have the knowledge and experience to design and install safe and effective electrical systems. Consider that NEC 250.24 an informational note explains in detail the rules about connecting to multiple buildings and how it can be achieved safely depending on the voltage and situation. Consider what the inspector is trying to accomplish, but more importantly, explain your concerns and the NEC code. They may be envisioning something different and have more information or context than you do, so it is important to work with them, not against them. When using metal conduit, electrical metallic tubing, or IMT, it can serve as the equipment grounding conductor, so long as all fittings are listed.